My talk is on solar thermal install, and I've done a number of talks, and I've focused more on solar energy in general and other topics, but since there's so many presenters in this expert series, I was trying to focus just on the solar thermal install and how it applies to this home. So this is an overview of what I'm planning on presenting. Can you see it? Okay.
Yes.
So I was going to quickly go over a little bit of my background, talk about the solar components on the house, a quick review of thermodynamics. There's some issues relating to heat that the more I think about them, the less intuitive they are. Talk about a basic domestic water heater that we install, which is also going to be sort of the basis for the home here. And then I'm going to talk about the proposed system that will go in this home once it's in its final location, and the system that's in the home today. I have a few sources of information, and then I have some other general information. I don't know if it's of interest to people on evacuated tubes and some pictures of installs and stuff like that. So my name is Brent Veitch, and along with Phil Foster here, I'm a co-owner of Rock Paper Sun. We incorporated in July of 2007, and we've installed about 50 solar domestic water heating systems, most of them in the Saskatoon area, but throughout the province. And maybe, I don't know, I'd estimate 10% or more are also doing some sort of space heating tied to it, mostly in floor applications that were already in customers' house. My background, I took electrical engineering at the University of Regina, and I have a systems degree there with a focus on process control. In 2010, so this last year, Phil and I started doing photovoltaic installs. Up until then, we focused solely on thermal installs. And other than solar, my hobbies include a little bit of woodworking, and I've just recently started getting into electric vehicles, plug-in hybrids, and stuff like that. This is a picture of my home. Both Phil and I are sort of practicing what we're preaching, and we both, the first year in 2007, we put solar thermal systems on our homes, and then in 2010 we put photovoltaic arrays. And this is, each of these suns is where a system, almost all of them are systems we've installed, but one or two are systems that we've worked on that other people have installed. And so you can see quite a few of them in the older neighborhoods in town, and not so much in the newer areas. This is us. We are here in the museum. So on the Verica home that we have here, there's 4 main solar components to it. The ones I'm going to talk about today are these flat panel solar thermal collectors and the system that they're tied to. There's also these along the top roof photovoltaic panels, and then the house incorporates solar passive heating, which is, if I could summarize Rob's presentation in a few words, it's a large amount of quality windows on the south and a really good thermal mass in the home. This home also has these evacuated tubes out front. They're partially plugged in, but they're not a functional system at this time. And they're primarily here as marketing for WSE Technologies, who's, I believe, a co-owner of the home. So before I talk about solar, I wanted to talk about heat a little bit. I thought about bringing a small experiment. Some of the other presenters have had physical items with them. As humans, we're immersed in heat. We deal with it every day, and we also deal with temperature and energy. And sometimes when we're so immersed in something, we don't think about exactly what they are or how they interrelate. So one thing I was thinking about is if I take a lot of people associate temperature with heat. the hotter something is, the more heat it has, or the more potential to heat. So if you take an ice cube and put it in this room, if I suspended it on an inverted, I have a plastic strainer that holds the ice cube up sort of, so it's in air on all sides. And the air in this room is at 23 degrees right now, 23 degrees Celsius. So if I have that ice cube 23 degrees Celsius, if I take another ice cube, a very similar ice cube, but put it in a glass of water, and the water's at, say, 10 degrees Celsius, the ice cube floating in the water, even though it's immersed in a colder fluid, will melt quicker than the one in air. So it's not the temperature, and both of them have fluid around them, so they have convective forces taking heat away from the ice cubes. They'll both eventually melt, but the cooler one melts quicker, and that has to do with the properties of heat transfer from the ice cube into the liquid are better than the heat transfer into the warmer air. So heat is a form of energy. It's a very basic form of energy, and two of the units that are common in my presentation, I use kilowatt hours as a unit of heat energy, and BTUs is also common to some people. There's about 3,400 BTUs in a kilowatt hour. So as humans, when we talk about heat, the heat in this room, we feel cold when our body loses heat to the environment, and I don't think anyone would challenge that. The next statement might cause second thought. We feel hot when we lose heat to our environment at a slower rate. We're not gaining heat from the environment to feel hot. That happens very rarely if our body is at 96 degrees Fahrenheit and the air around us is hotter than that. We can handle it for a little while, but if we sustain that for very long, we get in serious trouble. But we feel quite warm at temperatures lower than our body temperature. So when we're losing heat to the environment, but at a slower rate, we feel warm or comfortable, like this room, around 75 degrees, is it? 74. And it feels quite comfortable in here today. The floor is often a bit cooler. So we're losing heat to the air, we feel warm, we lose heat to the floor, and it feels a little bit cooler below our feet. So for a solar thermal system, the idea is to transfer heat from the sun into some medium that's of use to us. Traditionally, we do domestic water heating, so when the hot water out of your taps comes out hot, and in this house we're also trying to somehow heat the space that we're in, or heat objects around the space so that we don't lose heat to the space as quickly. So typically heat will flow from a hot object to a cooler object through a number of mechanisms that I'll talk about. But it's also possible to pump heat from a cooler object to a warmer object. And almost always when that happens, that heat energy changes state. It's either transformed into a different type of energy, or it's manipulated through state changes of fluids, such as an air conditioner would use. So there's three main methods of transferring heat or having heat flow. Conduction is probably the easiest to understand, and that's when you touch something that's at a different temperature. Heat will flow from the hotter one through to the cooler one, and then you can actually heat up. If I hold one end of this copper rod, over time that heat will be conducted through the copper rod, and the other end will also become warmer. Mechanical transport is even more basic and sometimes overlooked method of heat transport. If I heat up this copper rod and then I want to get heat over here, I can physically move the copper rod. For solids, it's not often thought of, but that's a primary method of transporting heat in our solar systems. And we use fluids as a transport mechanism. So we heat up a fluid in the collector and then we pump that fluid somewhere else, and then use conduction or other methods to get the heat out of the fluid. And radiation is